Hello everyone, in this video we will learn what are the different types of memory mode addressing modes are available. In the previous video we have learned what do you mean by addressing mode and what are the different types of addressing modes are available. The first type is memory addressing mode, and in that memory addressing mode there are various types are available that are immediate, direct, register, register indirect, register relative, base addressing, base index addressing, and relative base index addressing mode. The first type of our addressing mode is immediate addressing mode. So in that immediate addressing mode, we are writing the instruction as, for example, move AL, 46H. So whenever we are writing any instruction, that time first of all we have to write down the instruction mnemonics, then our destination operand, and then our source operand. So here whenever we are writing this instruction, that time we are writing here the instruction, then our destination, comma, our immediate value. So whenever we are writing the immediate value as a 48 or any other number, that time we are considering this addressing mode as immediate addressing mode. So here you can check in this example, in each and every destination operand will be there, and that consists of one of the register value. And whenever we are considering this source operand, which consists of the immediate data will be given, and that data we will consider as a source operand. So in case of immediate addressing mode, we are transferring the immediate value, that is the direct value, in our one of the register. Suppose you can consider that the first instruction is move instruction. So in that move instruction, we are copying the contents of 46 into our AL register. So our AL becomes 46H. Now the second instruction is move BX, 1234H. Whenever we are writing this instruction, this 1234H, that is the immediate value, will be copied into our BX register. So now our BX become 1234H. Now what is the next content? That is add AL, 12H. So whenever we are writing this instruction, that time what will happen? This immediate value will be added with our contents of our destination operand, because our add instruction is destination is equal to destination plus source. So we are writing here AL is equal to AL, 12H. So previously our AL consists of 46H. So we are adding here 12H, that is the immediate value, in our previous value, that is in our 46H. Then our result will be 58H. Now the current value of our AL register is 58H, because we are adding AL, 12H. Now here you can check that subtract BX, 1000H. So previously our BX is equal to 1234, and suppose we are writing here subtract BX, 1000H, that time what will happen? Our BX is our destination. So we are writing here destination is equal to destination minus source, and our source is 1000, and our BX is previously 1234. So 1234 minus 1000, it will become the content, that is 234, and we are writing here 0234H, and that will be stored into our BX register. So in that immediate addressing mode, whenever we are writing any instruction, that time we are writing the destination and the source operand. So source operand is always an immediate value of that operand. That is called as the immediate addressing mode. The second type of our addressing mode is direct addressing mode. So in that direct addressing mode, in the source and destination operands will be given in that instruction. So the first one is our destination operand, and the second one is our source operand. So in that source operand, the effective address of that particular memory location will be given, and we are performing the operation with that effective address of that memory location. So what you have to check whenever you are identifying this addressing mode? If suppose in that source operand, the address of that effective address of that memory location will be written directly in the instruction, so that this type of addressing mode will be considered as a direct addressing mode. So here in this example, the instruction is move AL, 3000H. So we have to check the contents of that memory location. So here in that 3000H location, the contents are stored, that is 80. So the contents of 80 will be copied into our memory location, that is in our AL register. So whenever we have to use that direct addressing mode, we are specifying the effective address of that particular memory location in our square bracket. So whenever the square bracket is included in our source operand, that time you can specify that the effective address is given, that is the memory location is given in that source operand. And that type of addressing mode will be known as a direct addressing mode. In the second example, the instruction is subtract bx, in bracket 8000h. So here there is a subtraction instruction. So how this instruction will be executed? Bx is equal to bx minus this 8000h. So we are writing here this 8000h as a memory location. So we are writing here bx minus in bracket 8000h. And on that 8000h location, what is your value? That is 1010. So here this is the 1000 location, and here the value will be stored as a 1010. And our bx contents are also given, that is 3020. So what will be your result? That is 3020 minus the location of that 8000, that is 1010. So whenever you are performing the subtraction, then you will get the result as 2010, and that result will be stored in our BX register. So what do you mean by direct addressing mode? In that direct addressing mode, the effective address of that particular memory location will be given in that source operand.